Welcome to the Deep Dive. We're your shortcut to understanding the really big shifts happening in tech right now. And today, we're taking a fascinating plunge into the ideas of Andrej Karpathy, specifically his vision for what he's calling Software 3.0. Now, Karpathy, for anyone who might not follow him closely, is a huge name in AI. We're talking former director of AI at Tesla, key researcher at OpenAI, Stanford background. Basically, when he talks about where software is headed, people really listen. And he's making a pretty bold claim. He argues that software is going through this fundamental change, something unlike anything in like 70 years. What's really interesting is he notes this isn't slow change. It's already shifted fast, twice in just the last few years, which means he thinks this is a really unique and amazing time to be building or even just, trying to understand the industry. So the core idea we're digging into today is this. We're entering a new era where natural language, just plain English, isn't just for talking to computers. It's becoming the actual programming interface. And the engine's driving this whole thing. Large language models.
LLM.
LLM. They're doing the heavy lifting now. Karpathy frames this whole history really nicely. He talks about software 1.0. That's the classic code, right? C++, +Vo, Python, Java, humans writing every single instruction. Then came Software 2.0. That was the shift to neural networks. The program wasn't code anymore. It was the network's weights, learned from tons of data, think image recognition, machine translation. And now, he says we're hitting Software 3.0, where prompts written in natural language are essentially programming the LLMs themselves. It's like we're directly instructing intelligence. He even has this cool map of GitHub analogy trying to visualize all the code out there, and you can kind of see how natural language is becoming part of that landscape. So our mission here is to unpack Karpathy's main ideas, pull out the key lessons, and give you, our listener, the practical takeaways if you're building or even just navigating this new world. Let's get into it.
Absolutely. And what's so useful right away is how Karpathy uses these really clever analogies to help us get our heads around what LLMs actually are. He kicks off by referencing Andrew Ng's famous line, AI is the new electricity. And when you look at LLMs that way, they really do act like utilities in a lot of ways. Think about it. OpenAI, Google with Gemini, Anthropic, they're spending huge amounts of capital, CapEx, just training these models. This isn't like buying a few servers. It's more like building the national power grid. Massive investment in hardware, data centers, just raw compute power. He talks about things like 1020 FLOPS clusters. I mean, FLOPS is floating point operations per second. 1020 is it's an astronomical number. It shows the industrial scale we're talking about, supercomputing centers, basically just for training.
Right. And then there's the operational cost, the OpEx, to actually run these things and serve them up through APIs. And just like we pay for electricity by the kilowatt hour, we pay for LLMs by the token. It's metered access. And we expect utility-like performance, don't we? Low latency, always on, consistent quality, like stable voltage from the grid. It really fits that comparison. It's infrastructure.
It totally is.
Yeah.
And the utility analogy keeps going. He mentions tools like OpenRouter. He sees that as like a transfer switch. You can flip between GPT, Claude, Gemini, whatever you need, just like switching your house between the grid, solar panels, or a backup generator.
Yeah.
That kind of redundancy and optimization. Classic utility thinking.
And we've all felt it, haven't we? What Karpathy calls intelligence brownouts when one of the major LLMs goes down. The impact is immediate. It's like the grid voltage dropping. Suddenly, things don't work right. Karpathy argues the whole planet literally gets dumber for a bit. If you've ever had ChatGPT flake out during a deadline, well, you know that feeling. Suddenly less productive, less capable. It's a bit unsettling, right? Thinking global intelligence hinges on server uptime.
It really is. But he doesn't just stop at utilities. He also sees similarities with fabs, semiconductor fabrication plants.
Yeah.
This goes back to the insane CapEx again, but also the deep R&D, the tech trees involved, and all the secrets held within these labs. He draws this direct line between, say, a 4-nanometer process node for chips and a 1020 FLOPS cluster for LLMs. So if you're training on NVIDIA GPUs, you're kind of fabless, like chip designers who don't own the factories. But if you're Google, training on your own TPUs, your tensor processing units, that's like owning the whole fab top to bottom. It shows the scale and integration happening.
Okay, so from utilities and fabs, he moves to what he thinks is maybe the strongest analogy, LLMs as operating systems. Because these aren't just simple commodities like electricity. They're incredibly complex software systems, right? Ecosystems. He points out how the landscape is looking kind of like the OS wars. You've got the big often closed source players like Windows or Mac OS, and then you see open source alternatives popping up like Linux. In the LLM world, yeah, you have OpenAI, Google, Anthropic as the closed giants, and then maybe the Llama ecosystem starts to look like the open source Linux equivalent. It's early days, but it's clear these things are more than just the model. There's tool use, multimodality, memory, how it all fits together. He sketches this picture where the LLM itself is like the CPU. It's doing the core thinking, orchestrating everything, and the context window, that's your RAM, your working memory. Looked at that way, yeah, it really feels like an operating system providing the core compute.
Exactly. And to make it super concrete, think about VS Code, the code editor. A developer can run that on Windows, Mac, Linux, no problem. Now look at an LLM app like Cursor, the coding assistant. You can run that on GPT-4 or Claude or Gemini. Often it's just a drop-down menu in the app. So the LLMs are acting as that underlying compute platform. They're a fundamental layer, just like Windows or Mac OS is the base layer for other software. And what Karpathy finds really striking is how much this feels like the 1960s. Back then, computers were insanely expensive, so they were centralized. Big mainframes and special rooms. We're basically in the mainframe and time-sharing era for LLMs right now. We're all like thin clients, right? Connecting over the network, sharing time in these massive centralized AI mainframes in the cloud. That's exactly how it worked in the 60s. The OS was remote, requests got batched, the whole personal computing V2 revolution. It hasn't quite hit yet, at least not for everyone. I mean, there are hints, right? Like people running some models locally on, say, Mac Minis for certain tasks. But widespread, cheap on-device LLM power, not really here yet.
That's a great point. And he observes that just talking to an LLM, like using ChatGPT in that text box, it feels a lot like using a command line, like talking to an OS through a terminal. It's direct, text-based. We haven't really invented the universal GUI, the graphical interface, for LLMs yet. Not one that spans everything. Sure, apps build GUIs around them for specific tasks, but there isn't that general-purpose visual way to interact yet. We're still mostly typing.
Yeah, and here's where Karpathy points out something really unique, something that flips the script. He argues LLMs seem to be reversing the usual direction of how technology spreads.
How so? What's the usual direction?
Well, think about most big transformative technologies. Electricity, cryptography, flight, even the early internet or powerful computers. They usually start with governments, maybe big corporations, because they're expensive, complex, needed for specialized things like military calculations or huge business problems. And then, only later, sometimes much later, they trickle down to regular consumers. They get cheaper, easier to use.
Okay, got it. So how are LLMs different?
Karpathy says it's the opposite. The first widespread uses were everyday consumer things, asking ChatGPT how to boil an egg, or drafting emails, or just playing around. The viral adoption came from individuals finding uses in their daily lives. Meanwhile, big companies, governments, they're actually lagging behind in many ways, still figuring out how to integrate these things deeply and safely.
Huh, that is backwards. So the innovation is kind of bubbling up from consumers.
Exactly. And that's a really profound insight if you're thinking about where the successful products might come from. It suggests maybe the killer apps won't be these massive top-down enterprise systems initially. They might be things that solve immediate, everyday problems for lots of people. It kind of challenges the typical startup playbook, you know? Maybe product market fit is hiding in plain sight in those simple consumer uses. Yeah, it's unprecedented. So, summing up this first big lesson, Karpathy sees LLMs as these complex new operating systems. It's like we're rebooting computing back to the 1960s time-sharing model. They're delivered like a utility, centrally managed. But the crazy part is the instant access for billions. ChatGPT just got beamed down to everyone overnight. It's an insane situation, he says, and that makes it an incredibly exciting time to jump in and start programming these new machines.
Okay, so if these are the new computers, the new operating systems, before we talk about how to program them, Karpathy really jumps into understanding what they are. He talks about their psychology, which sounds a bit strange, but it's a really useful frame.
It is. It's fascinating. He describes LLMs as people spirits. That's his term. He thinks of them as these stochastic simulations of people. Like the simulator is this autoregressive transformer, meaning it predicts the next word based on the previous ones, and it's been trained on just about all the texts on the internet. So by learning all those patterns of human language, human thought, human interaction from that massive data set, this simulator develops this emergent psychology that feels surprisingly human. It's a powerful way to think about it. It gives them this almost person-like quality, even though it's ultimately statistical pattern matching.
Right, this people spirit idea. And that leads directly to this duality he emphasizes constantly. LLMs have these incredible, genuinely superhuman strengths. but they also have these really significant critical cognitive flaws. And it's navigating this duality, he argues, that's key to building anything useful with them. You have to understand both sides. So let's start with the strengths. The most obvious one is just their sheer knowledge and memory. It's encyclopedic. They've processed more text than any human could read in countless lifetimes. The internet, books, code. Karpathy uses the analogy of Rain Man, the character with the almost perfect photographic memory. Calling phone books, complex numbers. LLMs are kind of like that. With information retrieval from their training data, they can pull up obscure facts, specific code snippets, even things like SHA hashes sometimes, with amazing recall. Superpowers and knowledge access, definitely.
Definitely. But then, the flaws. The cognitive deficits, as he calls them. And these are crucial to understand. First up, the big one. Hallucinations. We've all seen this. LLMs just make stuff up confidently. They might cite papers that don't exist, invent historical events, describe features a product doesn't have, and even though they're getting better, they still lack a solid internal sense of what they actually know versus what sounds plausible. It's not really a bug, more a feature of how they generate text probabilistically.
Yeah.
But it's a massive reliability issue.
Yeah, you can't just trust everything they say. Then there's what he calls jagged intelligence. This one's really frustrating sometimes. They can be brilliant at one task, maybe writing complex code or summarizing a dense article perfectly, and then turn right around and make a mistake that's just baffling. Like insisting 9.1 is bigger than 9.9 or saying strawberry has 2 R's.
Right. Mistakes basically no human would make.
Exactly. He calls them rough edges you can trip on. It means you can't just assume they're competent across the board. Their intelligence profile is uneven, jagged.
And another huge one, anterograde amnesia. This is fundamental. Think about working with a new colleague. Over time, they learn, right? They absorb context, remember past projects, build up expertise, they consolidate knowledge.
Okay.
LLMs don't do that, not natively. Karpathy explains their context windows are really kind of like working memory. Every new chat, unless you very carefully manage the history, is like starting fresh. They don't automatically get smarter or learn from past interactions in a persistent way. He uses movie analogies. Memento, 51st Dates. The characters whose memories reset every day. Their weights are fixed. Their context window gets wiped.
Wow, so you're constantly having to refeed them context. They don't build up long-term understanding on their own.
Exactly. That working memory has to be programmed in, managed explicitly. It's not built-in learning like humans have. A huge challenge for complex, ongoing tasks.
And finally, he mentions their gullibility, security issues.
Yeah, they're quite gullible, he says. Susceptible to prompt injection, where you trick them with clever inputs into doing things they shouldn't, like revealing private info or ignoring their instructions. Plus the risk of them leaking sensitive data they might have seen during training or in previous conversations. These are serious security and privacy hurdles.
Okay, so putting it all together, you've got these superhuman knowledge machines that are also prone to making things up, making basic errors, forgetting everything instantly, and being easily tricked. Karpathy's challenge to us is, how do we actually work with that? How do we harness the superpowers while mitigating or working around all these flaws?
That's the million-dollar question for anyone building products now. Understanding that weird mix of genius and deficit is step one.
Which leads perfectly into Karpathy's core advice for builders. His big lesson, framed by that brilliant Iron Man suit analogy. Think about Iron Man, right? The suit is partly an augmentation. Tony Stark is in there driving it, making it an extension of himself, boosting his own abilities. But it's also partly an agent. It can fly on its own, perform complex tasks autonomously. Karpathy's point, given how flawed LLMs still are, is that right now we should be building less Iron Man robots and more Iron Man suits. Meaning, focus on products that offer partial autonomy, tools that augment and empower the human, rather than trying to replace them with fully autonomous agents that are likely to, well, crash and burn.
Exactly. It's about pragmatism. And that Iron Man suit idea translates into some really clear design principles for what he calls partial autonomy apps. The absolute foundation is build with a human in the loop, always. Take coding, for instance. You could just chat back and forth with raw ChatGPT, copying code, pasting errors, talking directly to the OS, as he puts it. But why would you? Instead, use something like Cursor. Karpathy holds it up as a good early example. Cursor gives you a normal coding environment where you, the human, are still writing code, making decisions, but it integrates the LLM to help with bigger tasks, generating functions, finding bugs, refactoring. It augments your workflow. The human is still the pilot.
Okay, so human in the loop is number one. What else makes these apps effective?
He highlights a few key properties. First, Context management. Good LLM apps need to handle the context for the user, mostly behind the scenes. Like Cursor figures out which files are relevant, uses embedding models to understand your code base, manages the chat history, even applies the code changes, diffs. The user shouldn't have to constantly spoon-feed the LLM all the necessary background info. The app should be smart about context.
Makes sense, takes the burden off the user.
Second, and this is huge for the Iron Man suit idea, an application-specific GUI. A graphical interface tailored to the task. Why? Because auditing and verification need to be fast. Just reading walls of text from an LLM is slow and tiring. But a visual GUI, that taps into, as Karpathy says, the computer vision GPU in all of our heads. We process visual info incredibly quickly.
Like seeing code changes highlighted in red and green.
Exactly. Way faster than reading a description. Or using keyboard shortcuts like Command-YN to accept or reject suggestions instead of typing out yes or no. GUIs make it easy and fast for the human to check the LLM's work, which is essential given their flaws.
Okay, GUI for speed. What else?
Then there's the autonomy slider. This is a really key concept, giving the user control over how much the AI does. Think about Cursor again. You have simple, autocomplete, mostly human control. Then maybe Command-K to let it change just a selected block of code. Then Command-L for a whole file, all the way up to Command-I for more agentic mode where it tries to tackle a bigger task across the whole project.
So the user chooses the level of intervention.
Precisely. You slide the autonomy up or down based on the task, your confidence, the risk. Perplexity does this too, right?
Okay.
Quick search, deeper research, even that mode where it goes away for 10 minutes. Different levels of letting the AI take the reins. The user stays in control of that slider.
This slider idea flows right into the next critical point, managing the generation verification loop. The AI generates, the human verifies. That's the core loop in most LLM applications today.
Yeah.
And Karpathy hammers this home. You need to make that loop as fast as possible. Productivity hinges on how quickly the human can check the AI's output.
So how do you speed it up? Two main ways he points out. First, speed up the verification itself. That goes back to the GUI. Visual diffs, easy accept reject buttons, making it effortless for the human brain to audit the output. A good GUI is a highway to your brain, he says.
Okay, faster checking. What's the second way?
Keep the AI on the leash. This is crucial. Karpathy warns against getting carried away with fully autonomous agents right now. He makes the point. Getting a 10,000-line code diff, even if generated instantly, isn't actually helpful.
Why?
Because the human still has to review it. That's the bottleneck. Exactly. You have to check for bugs, security holes, make sure it's actually doing the right thing. It's overwhelming. So his advice is, work in smaller chunks. And give the AI very specific concrete prompts. If the prompt is too vague, the AI might get lost in the woods, generate junk, fail verification, and you waste time and money starting over. He gives an example from education. A teacher app could create a structured course artifact first. That artifact then acts as a leash for the AI generating lesson plans, ensuring it sticks to the syllabus. Much higher chance of useful, verifiable output.
That makes a lot of sense. And Karpathy's own background really reinforces this, doesn't it? Building Tesla Autopilot.
Absolutely.
Yeah.
That was his life for 5 years, building a partial autonomy product. And it had these exact features. The Tesla screen showed what the AI saw, the cars, the lanes. That's the GUI for verification, giving the driver transparency. And the autonomy slider was there too. Over time, Tesla added more capabilities, lane keeping, then adaptive cruise, then handling lights, turns. But the human was always ultimately in charge, could take over instantly. It was augmentation first.
He also tells that story about riding in a Waymo way back in 2013, right?
Yeah, a really formative experience for him. A 30-minute drive, perfect, zero interventions. He thought, wow, self-driving is imminent.
But here we are over a decade later.
And while Waymo is driverless in some places, it's still geographically limited, still involves remote human assistance, teleoperation, for tricky spots. Full, generalized autonomy hasn't been solved. Karpathy uses this to illustrate the huge gap between a demo and a real product, the demo-to-product gap. A demo just needs to work once, works on any. A product needs to work all the time, reliably, safely, economically, works.all. Bridging that gap is incredibly hard work.
So that experience makes him skeptical of overhyped timelines for full autonomy.
Very much so. When people say 2025 is the year of agents, he pushes back gently. He suggests thinking more like 2025, 2035 is the decade of agents.
Yeah.
It emphasizes that this takes time, requires serious engineering, and crucially, keeping humans in the loop for the foreseeable future. Build the Iron Man suit first, make it better and better, before expecting the fully autonomous robot army. Which brings us to the next big implication Karpathy draws from all this. It's not just about how we interact with LLMs. It's about how they will interact with the digital world. His call to action here is fundamental.
Yeah.
We now need to consciously build for agents.
Build for agents. What does that mean exactly?
It means recognizing there's a new kind of user out there.
Yeah.
It used to be just humans using GUIs, right? Clicking buttons, filling forms. Or it was other computers using APIs, structured data exchange. But now, Karpathy says, we have agents. These LLMs, these human-like people, spirits on the internet, they are becoming consumers and manipulators of digital information too. And our current websites, our current apps, our current documentation,
Yeah.
they weren't really designed for these people spirits to interact with effectively.
So we need to redesign things so agents can understand and use them.
That's the core idea. Can we adapt our digital infrastructure to make it accessible and usable for this entirely new category of user? It's a major shift in thinking.
Okay, so what does that look like in practice? Karpathy gives some concrete examples, right?
He does. Really practical stuff. First, he talks about agent-friendly documentation. We already have robots.txt to tell web crawlers what they can and can't scrape. Karpathy proposes something similar for LLMs, an lm.txt file.
lm.txt.
Yeah, just a simple markdown file at the root of your website or service. It would clearly explain in structured text that an LLM can easily parse what the site is about, what services it offers, maybe how to interact with its API. This is way better than forcing an LLM to try and scrape and understand messy HTML, which, as he notes, they often screw up.
So like documentation specifically written for the AI.
Exactly. He points out companies like Vercel and Stripe are already putting their docs out in markdown format, partly for this reason. It makes them more digestible for LLMs. He even shared a story about using an LLM to generate code for Manum, that math animation library. The docs are famously dense. Instead of reading it himself, he just pasted the ManBank docs into the LLM and described the animation he wanted, and boom, the LLM spat out the code. That shows the power of making docs legible to these models.
That's a great example. Okay, so better docs. What else?
Actionable instructions. This is key.
Yeah.
So much of the web and software documentation says things like, click here, drag this, go to the settings menu.
Right. An LM can't click a button.
Not easily or reliably anyway. It requires complex vision models. It's error-prone. Karpathy notes Vercel, again, they're actually changing their documentation. Instead of saying click this button to deploy, they provide the equivalent curl command or CLI instruction.
Ah, something the LLM could actually execute programmatically.
Precisely. Or an API call. It makes the instructions directly actionable for an agent. He also mentions Anthropic's Model Context Protocol, another effort to create structured ways for agents to understand how to interact with systems beyond just guessing from natural language. It lets them do things.
Got it. So machine-readable docs, actionable commands. Any other examples?
Yeah, he talks about the need for context builders for LLMs.
Okay.
Tools specifically designed to package information in ways LLMs can easily ingest. He mentions Gitingist. You know how GitHub repos are structured for humans?
Yeah, folders, files.
Gitingist is this cool tool where you can basically swap github.com and the URL for gitingist.com on a public repo. It instantly concatenates all the code files into one giant text file, but keeps the file names and structure visible.
Oh, wow. So you can just copy-paste the whole repo's content straight into an LLM.
Exactly. Instant context dump. Perfectly formatted for the LLM to understand the whole project. And then there's DeepWiki from the team behind Devin, the AI coder. That goes even further. It actually analyzes the repo and builds whole documentation pages specifically structured for LLMs to understand the code base. More than just concatenation, it's analysis and synthesis for the AI.
So these tools are like pre-processors, getting data ready for LLM consumption.
That's a good way to put it. And Karpathy's overall point here is about meeting halfway. Sure, eventually LLMs might get really good at navigating websites like humans do, clicking stuff with vision models. But right now, it's much more efficient, much cheaper, much more reliable to just make the information easier for them to access directly. Structured text, clear commands, ingestion tools. Especially for all the existing software out there, the long tail that won't get a fancy new agentic interface overnight. Making data agent friendly now is the pragmatic path forward.
Okay, so as we start to wrap up this deep dive on Karpathy's Software 3.0 vision, the main feeling I get is one of huge optimism, right? And just opportunity. He keeps coming back to this idea that we're right at the beginning, like the 1960s for operating systems. It feels incredibly early.
Yeah, the landscape is wide open.
And it's a massive call to action, time to build. He really emphasizes that. He sees so much software needing to be rewritten or rethought for this new world, and not just by traditional engineers. He talks about vibe coders, people just using natural language to create things. It feels like a democratization is happening.
It does. And just to recap those key takeaways for everyone listening, remember, Karpathy sees LLMs as these complex complex people spirits, superhuman strengths like memory, but also critical flaws, hallucinations, jagged intelligence, that instant amnesia. Understanding that duality is job one. And it means building partial autonomy products, Iron Man suits, not robots. Keep the human in the loop, design for a super-fast generation verification cycle, use GUIs effectively, keep the AI on a tight leash with specific prompts.
Right. Augment, don't replace, at least for now. And think bigger picture, too. Start building for agents. Make your documentation readable for them. Make instructions actionable. Use tools to help them ingest context. They're the new users.
It's a fundamental shift. This really is a time to build in a completely new kind of computing era, an era where software talks back.
And Karpathy's prediction is clear. Over the next decade, that autonomy slider we talked about, it's going to keep moving, shifting slowly but surely from human augmentation towards more agentic capabilities. We're just starting that journey.
So the big question Karpathy leaves us with, the question for you listening, is how are you going to contribute? What systems will you build? What problems will you solve as that slider moves from left to right?
Right.
What does software 3.0 look like when you build it?